We need only keep the coil rotating in the magnetic field to continuously induce electric voltage and current. But current produced in this fashion has an interesting feature. It is alternating. We can better understand this characteristic if we study the coil's rotation. Note that the particles flowing through the circuit represent electrons, but keep in mind conventional current flow is opposite in direction. By looking at this simple generator, we can see most current is produced when the conductor passes through magnetic lines of flux at the fastest rate. That is, the greatest current occurs when the conductor moves at right angles to the magnetic field. Then, as the conductor continues its rotation at a constant speed, it cuts through fewer and fewer lines of flux, and less current is induced. Eventually, the conductor moves parallel to the field. At this point, no current flows because the conductor doesn't cut through any lines of flux. This occurs twice in each revolution. Notice, as the coil rotates, one of its sides cuts downward through the magnetic field, causing current to be induced in one direction, while the other side is moving upward, inducing current in the opposite direction. After the coil passes through the position of no current flow, the previous downward side moves up, and the previous upward side moves down, thus reversing the current flow in the external circuit. This, then, is alternating current, a flow of current in a circuit that reverses direction periodically and is continually varying in magnitude. So how can we construct a source of direct current? Obviously, we must find a way to maintain current flow in one direction in the external circuit. To do this, we need change only the slip rings, which collect alternating current, to a commutator which will rectify, that is, change, AC to DC. The commutator is a collar divided into segments, insulated one from the other. We attach one end of the coil to one of the segments and the other end to another segment. Now, as the coil rotates through the first half cycle, the induced current of one direction is collected from the commutator segment. It flows through the external circuit, then back to another commutator segment and into the coil, completing the circuit. The brush that connects the commutator to the external circuit breaks the contact with the first commutator segment and makes contact with the second. As we've seen, the induced current in the rotating coil is opposite in direction from that of the previous half cycle. But the commutator switches the coil connections to the opposite side of the external circuit. In the external circuit, the current generated from the second half cycle is in the same direction as that generated from the first half cycle. The commutator has rectified the current, converting it from an alternating current to one that flows only in one direction, direct current. But there is a problem. The direct current produced by a single coil is pulsating and unsuitable for most applications. Therefore, practical generators have many coils and many commutator segments that can produce a voltage that pulsates very little and is usable.